trees inside of me. In this desert I can look at you with love, seeing all that I can learn. Can you stay and I will grow the hanging gardens of Babylon. Love, 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 I wanna be strong.
Hi to all. Today we will discuss how to draw a cycloid for a given circle of diameter 5 cm. Okay. So take the given data. Draw a cycloid of a circle of diameter 50 mm for one revolution. Okay. And we have to draw the cycloid for complete one revolution of the circle. Also draw a tangent and normal to a curve at a point 35 mm above the baseline. First we will do the cycloid. After that we do the normal and tangent to the cycloid. Here take the diameter of the circle. So it is 5 cm. Just do one circle. Okay, this circle is making complete one revolution. So this circle of 5 cm diameter, this is the diameter. This circle is making one complete revolution. So it is moving the peripheral length of the circle, periphery of the circle. So what is the formula for peripheral of the circle? 2 pi r, where 2 pi is, where r is here radius of the circle, 2.5 cm. Okay, do with calci and take down those values. 2 into pi into 2.5, 2 pi r. So this value is 15.7 centimeters. This length is from one of the point on the circle to the last point is 2 pi r. So the circle is moving in complete one rotation. It is moving from this point to 2 pi r distance, that is 15.7 centimeter distance in one revolution. Okay, here for doing the cycloid we have to divide this circle into 12 equal divisions. We can make it into 6 divisions also, but for getting all the points for doing the cycloid neatly, we have to divide this into 12 equal divisions. Doing the cycloid, first we will do the circle at O as center. Okay. So take radius is 2.5 cm. After doing this circle, draw horizontal diameter and vertical diameter at the center. As we know, horizontal diameter, vertical diameter 90 degrees to each other. After this, take the vertical diameter just for getting perpendicularity. I am taking this as a reference. Just do one line here. So I am taking this is 90 degrees. That's why I am using this set square. Now here after this, divide this circle into 12 equal divisions. Already I told dividing the angle at the center is 360 degrees into 12 divisions. We have to take 30 degrees each part. So by using the protractor, I am dividing this circle into 12 divisions. So mark 30 degrees here. So this is the reference line, horizontal diameter and vertical diameter. Here 30 degrees, after 30 again 30 degrees, means it is at 60 degrees. 90 degrees already we did line. After that 120 degrees, and then after that again 120 plus 30 means 150 degrees. Okay. We got these points. So join these points to C with the help of scale. Join this point to C. So within circle, do the line and extend the line this side also, because the circle is symmetrical about horizontal axis and vertical axis. And after getting one line here, take this point and join with center and extend this side, and take this point, join with center. And take this point, join with center. Now here we have divided into 12 equal divisions. Mark the points on it. I am starting, first point is here. This is the second point, third one, fourth point, fifth point, sixth point, seventh point, 8.9, 10, 11. This is the 12th one. After dividing this circle into 12 divisions, okay, take initial point is P point here. Okay, I am taking 12th point as P point also. Okay, here do this distance 2 pi r distance from this point because it is making one complete revolution, okay. So it is moving 2 pi r distance. 2 pi r length is 15.7 centimeters. So here do the line 15.7 centimeter. I am using this roller scale for doing the parallel lines. I am taking this is a reference, and just I am taking this line as a reference at the 0. Just move the scale in downward direction at this point, from this point to 15.7. Mark the end point and join this point to this point. Okay, this distance is 2 pi r distance. Okay, so on this circle is moving clockwise. It is rotating on this line. Okay, now whenever the circle is rotating, okay, as I told, all these points are coming on this circumference, that is 2 pi r distance. That's why we have to mark these points here also at equal distance. Okay, so we have to divide the complete this distance into 12 equal divisions. So how to divide any line into some equal divisions? We have one method in engineering drawing. Just do one line here, inclined line of some angle. First take one inclined line here. After doing this inclined line, take some radius, any radius we can take here by using compass. Initially this P as center, just do an arc here. Okay, and take this intersection point of this arc and this inclined line as center. Take the same radius, do an arc, again do an arc. Like that we have to divide into 12 divisions. Let us count first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here one arc will come, 12th arc. Just extend this line for getting the intersection point. Now these are the divisions, equal divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. For getting the 12 divisions, take this last point. Okay. Join this last point to this last point of this line. Okay. Just do with the help of scale. Join these two end points. Okay. And I am using roller scale for getting the parallel lines at all the points. So after getting this line, okay, we have to do parallel lines, okay, parallel to this line at all these points. Okay. For getting the parallel lines, I am using roller scale. I am taking this is a reference line. So move the scale in this direction, in upper direction at this point. Just do one line. Similarly, move the scale, do the line. Here after getting these points, intersection points, give the names for these points. I am taking this point, one will come here, I am giving 1 dash it is. This point is 2 dash, this point is 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and this is the last one, 12 dash. Okay, so this is the method of dividing any line into equal number of divisions. After getting these intersection points, here as I told, circle is rotating from first point here. So it is coming at 1 dash, it is coming at 2 dash, next it is coming at 3 dash, again it is coming at 4 dash, like that. If circle is making rotation, the centers are also changing. Okay, if you take here, now previously center is C, now center will come here. So centers are also changing, but all centers are coming on the same line. Okay, so that's why what I am doing is, I will extend this center line also up to this end point. I am marking C1, C2, C3 like that up to C12. Here also do one line up to this end point, mark C1, C2, C3 on it. So take this line as a reference line, do one center line. Okay, and here do the end line here. So mark on the center line C1, C2, C3. As we know, for when the circle is from this point to 1 dash, center is moving on the center line. Okay, whatever distances here we are taking, so mark the same distances on it for the centers also. I told this circle is rotating. Okay, we are getting the new points here, and centers also coming new centers C1, C2, C3 like that. So the distance is same here. Okay, so do at all the points vertical lines for marking the centers. So take this is the reference. At 1 dash mark the center. Similarly at 2 dash do the vertical line. At all the points do the vertical lines. Point of this first line and center line is C1, and second line to this center line C2, and third line C3, and fourth line C4, C5, C6, C7, C8, C9, mark the end point here initially. Already we did one line here, just extend this line. Okay, and here also at 6 do the horizontal line. Take this is the reference line. So after getting this line, all points are also moving, so from all points do the horizontal lines. So 7, 5 is symmetrical, so do the line passing through 7, 5, 8, 4, and then already 9, 3 is coming on the center, and 10, 2, and then 11, 1, here. After getting these lines, our main aim is we have to do the path of P point. P point initially here, circle is moving from C to C1, where the P point will come. When the circle moving from C1 to C2, where the P point is coming, this is the P point, initial point. Okay, so here I am taking one example. This is a circle, this is the P point I am taking. Let us take circle is moving from one point to another point. So P point is coming here, again circle is moving, P point is coming here, initially it is here, it is moving here. Now circle is moving, so P point is coming here, from this point to this point. Okay. Similarly, so it is coming here, after that P point is coming here. Okay, like that the P point is, we have to draw the path of this P point. Okay, when the circle is moving from center C to C1, C1 to C2. Main aim is we have to draw the path of P point when the circle is moving from one position to another position. Okay, so here the center distance and this P point, okay, this center distance and P point is constant, that is the radius of this circle. Okay, so radius is constant here, that's why whatever radius of the circle is there, because P point is at the circumference here, so whatever radius here we are taking, it is the same distance. Okay, now initially P is at the center line. Okay, now C is moving from C to C1. I am taking the curve from the, I am doing an arc on the first line. So initially P point is this point. Okay, so the distance from center to P point is radius. Okay, now it is moving from C to C1 circle. What about the P point? So just take C1 as center, take the same radius, do an arc on the first line, the line passing through first point. Take the same radius, C2 center, do an arc on the second line which is passing through 2. Similarly take C3 center, just do the line on the third line which is passing through 3. Okay, so this initial line is passing through 1, the second line is passing through 2, the third line is passing through 3. Similarly C4, same radius, do an arc on the fourth line which is passing through 4. Similarly C5, do an arc which is passing through 5. Similarly sixth, this is a sixth line, okay, on the 6th one. And next C7, we have to do an arc on the 7th line. So this 7 5 is coming on the same, do this side, okay. Similarly C8, where is 8.8 and 4 on this line, so we have to do an arc on the 8th line. C9, okay, on the 9 3 are coming on the center, so on the center line. And then C10, C10 means this is a 10th line, okay, on this line we have to do. And then C11 on the 11th line, so C11 on the 11th line, like this. And C12, again it is coming at this point, last point, 12th point. After getting these arcs, give the names for it. The arc and the first line intersection point I am taking, it is P1, and this arc and the second line intersection point is P2, and after P2 this is a third line P3, and fourth line this intersection point P4, and next for fifth line the intersection point is P5, and this point is P6, and then seventh line curve is P7, and eighth line and this intersection point is P8, and then this arc and ninth line P9, 10th line is P10, and this is P11, and the end point is here P12, it is P12, okay. Now join all these P1, P2, P3, P points to this P point and here P12 point. We will get the cycloid. Just do a freehand curve. Join this side points. This curve is called cycloidal curve. Make it dark. This is a cycloidal curve or cycloid. Here for this cycloid we have to do normal and tangent at a point 35 mm above the baseline. So this is the baseline. So above the baseline 35 mm we have to take one point on it. So from the baseline the point should be 35 mm. So for marking this I am taking the roller scale. I am keeping here 35 above the baseline. Now move the scale in this direction. So it is touching at this point. Take this point is M point. At this M point, so for doing normal and tangent at M point, take the radius of the circle, okay, and M as center. Just do an arc on the center line, okay, and mark this name is intersection point is here X, okay. Here draw the vertical line parallel to these lines. At X, do the vertical line. Give this intersection point is N. Join N and M, it is a normal. Join this N point and M point up to some distance. It is a normal to the curve. Take at some distance. Just do up to some distance. So this N, this point is N dash. This is the normal to this curve. And do the tangent. As we know, tangent is perpendicular to the normal. So take perpendicular means 90 degrees. So at this M point, this is the normal, and tangent will come so in this direction. So join this point to M. So take one line. So this is the tangent. T dash is the tangent. Okay, this is the method of doing the normal and tangent for this cycloid. This angle between tangent and normal is 90 degrees. Okay, mark the given dimension. Okay, the diameter is 50 mm. This distance is peripheral length 157 mm. So mark the dimension in mm. So this is the process of doing a cycloid for the given circuit for one revolution.